class to my teachings of solids of a revolution. Okay, my name is Professor PaulieBoomandJun, and I'll be teaching this lesson. So, when you see this type of question on your AP, the first thing that should pop into your head are the two different ways to solve it. You have the disk method and the washer method. Now the disk method has a unique formula. It's pi times the integral of r squared dx. Similar to the washer method, which is its formula is pi times the integral of the difference big R squared minus little r squared dx. The disk, if you take a cross-section of disk and rotate it around the x-axis, will come out like a disk. If you take a cross-section of a washer problem, it'll come out looking like a washer with a hole in the middle. Why? Because the graph isn't flush with the x-axis. Okay? Alright, welcome to my class. My name is Professor PaulieBoomandJun, and I'll be teaching solids of revolution. Here we go. So, when you're taking the AP, you're going to see the problem come at y1 is equal to radical x, and y2 will be, what do you want it to be, huh? We'll do it 0. y2 is equal to 0. You're going to have bounds on this problem as well. So it'll be for x is equal from 0 to 9, alright? Now, what does this look like, huh? You need to picture it in your mind. I'll draw it out for you. The graph will look like this. Alright? From 0 to 9. We want to get the area from 0 to 9 and revolve it around the x-axis. Solids of revolution. Key there. So let's go. Now we have this in our mind. Okay? We'll write down the formula. Pi times the integral of r squared dx. Why do we use the disk formula? Well, I'll tell you why. Because the graph is flush with the x-axis, okay? So, these Arab too skip. So, now we'll plug in for r squared, but oh snap, what's the radius? The radius is radical x. Why? Because the cross-section will be equal to radical x. Yeah, you got it. So it's pi, the integral of radical x, all squared dx. Don't forget that squared, it's very important. So, after we get this, we'll start integrating. Oh, I forgot to say 0 to 9 for the bounds. Yeah. So, now the radical and the squared cross out, so it's pi from 0 to 9 of x dx. Okay? Remember that. Need to erase some stuff. Alright. Remember this? Good. We're going to continue now. So now we're going to start integrating. So it becomes pi of x. You raise x to its power, so squared all over 2 from 0 to 9. So now what do? We plug in the 9 and then we plug in the 0. So you get pi times 9 squared all over 2 minus 0 squared over 2. What is this equal to? This is equal to pi times 81 over 2 minus 0. Okay? Right? So now we get 81 pi over 2. What is that equal to? This is equal to your volume. And that's your final answer to the problem, because what we were looking for in the beginning was the volume of a revolution. This is the volume as the graph goes across the x-axis. Thank you, and good night. Yeah.
Hey AP Calc kids, so today we're going to be going over how to find the volume using a given cross-sectional area. So in the AP they're basically going to give us a shape. Right now we have x squared plus y squared equals 9, which is a circle. And we're going to be looking, it's almost going to be as if we're looking down to the base of the circle. and it can be any three-dimensional shape. It can be a cone, it can be a cylinder, it can even be like a curved pattern over here, you know. But the good thing is that we don't really have to know what the three-dimensional shape is, because we can just cut these up into slices and find the area of the slices, add them all up to get the volume. So they're going to be giving us what shape to use for the slices, and here let's use squares, okay? So to find the volume, we're going to add up all the slices of the squares, just from A to B, and the area of a square is s squared. And since this shape, in the question we're doing right now, this shape is perpendicular to the x-axis, we're going to be solving this equation in respect to the x-axis. So here we have a formula for the volume. Now, since our radius is 3, obviously, the integral is going to be from -3 to 3. It's -3 to 3. But how are we going to find the side? First we're going to solve for y. So y squared equals 9 minus x squared, and then we get the square root, and y equals radical plus or minus 9 minus x squared, okay? So here we have the side basically, which is right here, or here. It can be anywhere, alright? So the top portion is going to be radical 9 minus x squared, and the bottom portion is also going to be 9 minus x squared. So basically, the side of the square is going to be 2 radical 9 minus x squared. So let's put that in. Side is going to be this, and we square that, because the area of a square is s squared, and dx. Let's pause it. Hey guys, so welcome back to AP Calc class, okay? I just cleaned up the board a little bit, and this is where we last left off. So we're gonna now simplify this a little bit, and it's gonna be the integral from -3 to 3, 4 minus x squared dx, okay? Because the 2 squared becomes 4, and the radical gets cancelled out by the square. And we're gonna simplify this even further, so it's gonna be the integral from -3 to 3, 16 minus 4x squared dx. Alright, now let's solve for this. What's the antiderivative of 16 minus 4x squared? Can anybody tell me? No, you cannot. So the antiderivative is going to be 16x minus 4 over 3 x cubed, -3 to 3. Now, I know you guys are bright young students, okay? So we're gonna skip over, how to do this section, because I know you guys all know it, and skip over to the numerical values. It's gonna be 216 minus 108, and it's gonna be 140. That's gonna be 144, and that's our answer right there. 144. Can everybody clap?
Clap. Come on, guys. Clap.
Come on, guys.
You got the answer.
You got the answer. It's 144.
Clap.
Clap.
Yay.
Yay. Alright. Alright.
Yay. Alright, thanks guys.
Alright, thanks guys. I'm done with my calc project. Bye.
You had one, Ryan.
Alright, that's good.
And I was short, so that ending one is good.